This is a tutorial for working out application problems using the Poisson distribution. Applications usually involve calculating the average, lambda, or conditional probability. We normally use formulae or possibly probability trees to help work out application problems. Looking at our first example, in the Southwest Pacific, cyclone season runs from November to April every year. The probability that this region will experience at least one Category 3 or higher cyclone during the season is 0.9959. Find the average number of Category 3 or higher cyclones that the Southwest Pacific experiences per season. This is an example of an inverse Poisson question where we are given a probability and asked to work out lambda. Let's first write down what we know from the question. So we know the probability of at least one cyclone is 0.9959. From this, we also know that the probability of 0 cyclones occurring is 0.0041. To be able to progress with an inverse type question, you must know the probability of 0 events occurring. That's this probability here. Without that, we can't go any further in this type of question. So now we can fill in our Poisson formula, and I have put this just above, so we'll bring that down now. Filling in the formula, we know that x is 0, and we are trying to work out lambda. So we can simplify this equation down. To e to the power of negative lambda is equal to 0.0041. This is because any number to the power of 0 simplifies down to 1, and 0 factorial is also equal to 1. So both of these drop out of our equation, and we are left with what is written down. The next step is to take natural logs of both sides. And it does need to be a natural log because our Poisson formula uses Euler's number E. E and a natural log are inverses of each other, so they are opposites. And natural log is different to your normal log base 10. So lambda is equal to 5.5 to 1 decimal place. So we can conclude the Southwest Pacific will experience an average of about 5.5 Category 3 or higher cyclones per season. Taking a look at our second example, over a long period of time, the number of accidents per day on a certain stretch of State Highway 1 has been found to have approximately a Poisson distribution, with a mean of 1.5 on weekdays and 3 at the weekend. If there are no accidents on a particular day, calculate the probability that it is a weekday. This is an example of a conditional probability that we are going to use a tree diagram for. So drawing that first. We are going to use a Poisson distribution to fill in the two highlighted branches on the diagram. Working on that now. So on a weekday, we have a Poisson distribution with a lambda of 1.5 accidents, and we're trying to find the probability that there are no accidents. And for a weekend, we have a Poisson distribution with a lambda of 3 accidents, and the probability of no accidents is 0.0498 to 4 decimal places. This is what we're going to fill in on the highlighted branches of our diagram. Now we are ready to work out the conditional probability. So we are wanting to find the probability that it was a weekday given no accidents occurred. I know that from this last bit in the question here. If there were no accidents, so that's my given part, calculate the probability it was a weekday. Using our conditional probability formula, We can rewrite this as the probability that it was a weekday and there were no accidents over the probability that there was no accidents. Now I can find these needed probabilities from the tree diagram above. And the bottom line is following the pathway we highlighted before, added to this pathway here. So both pathways ending with no accidents. Working this out, so we can conclude the probability that it was a weekday, given no accidents occurred, is 0.9180 to 4 decimal places. There we have two examples for application problems, one which involved an inverse Poisson problem and the other one that involved a conditional probability.